So another example of a derivative function. So example, determine the derivative to f of x equals, and another one that we did earlier today was this one. And I think we did this one at what point? What point did we choose that one at? I'm asking my studio audience. We took it at 3? So at x equals 3, so, and what was the answer? So we know this from earlier today. So what we're going to do is do this in general and see if it works, just for fun. So the derivative function, by definition, is the limit. I'm going to do it with delta x's this time, just to bug you. Delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now, once again, the biggest difference here is that's not a number, because we're not taking it at a particular value. So it's going to be the limit as delta x approaches 0 of square root x plus delta x minus 2 subtract x minus 2 over top of delta x. Notice if I allow delta x to approach 0, I'm going to get 0 on the top and 0 on the bottom, so we've got some work to do. So I'm going to multiply by the conjugate. And it's going to be x plus delta x minus 2. Notice how I extend that. I don't let the negative 2 just hang out. Plus x minus 2 over top of root x plus delta x. I don't really need the brackets. Plus x minus 2. So this is going to become the limit as delta x approaches 0 of x plus delta x minus 2, so it's the first term squared. Subtract the second term, but it's the whole second term, so notice I put brackets in there. Over top of delta x, x plus delta x minus 2, plus x minus 2. Limit, delta x approaches 0. So this is minus x, that's going to cancel with that one, that's going to be a plus 2, that's going to cancel with that one, so I'm going to be left with delta x over top of delta x, x plus delta x minus 2, plus x minus 2, end bracket, reduce, turn on the limit, and we come up with a final answer of 1 over 2 root x minus 2. And we determined what x equals 3 was, so if x equals 3, we would determine f prime of 3, which would be 1 over 2 root 3 minus 2, which would be 1 over 2. And lo and behold, it works. But what's really nice about it is I can now do it for any value. And that should be rationalized, which is root 2 over 4. And I can keep going and going and going for any values of x that I want for which the function is originally defined. So the only difference is we've put in an x value. Okay? I'm going to stop there, and we'll be back in a minute.